All right, here we go. Let's take a look at 18. Oops, what's that mess? All right, let's see what we got. Okay. Let's see. What would I give for the answer for that? Because I think this is another misprint. It is. Yeah, this is another misprint. Okay, I won't have a misprint on the test, but it should be less than or equal to. Remember, we had that on the other worksheet. For some reason, I guess when they programmed those problems in, they must have messed up, and then every time you like regenerate the problem to get a new one, it does it the same exact way. So 18 should be less than or equal to. So that might clear up your question, but we'll do it anyway just for fun, okay? Because if it said greater than or equal to, your errors would be going out, but this one, everything was in, and less than or equal to makes it go in, all right? So let's do this. Let's add a 4 to both sides, and that's probably where you had the question, isn't it? It's negative 5 less than or equal to 4x less than or equal to 5. Divide by 4. Okay, so I've got negative 5/4 is less than or equal to x, which is less than or equal to positive 5/4. Alright, then they do want you to graph this one, don't they? Alright, so I put negative 5/4 right here, and I put positive 5/4 right here. And it says, basically, when it's going to the left like this, less than and less than, it means this is in between these two numbers. All right, so it's greater than the negative, so it's greater than this one, but it's less than this one, and it's or equal to. So right, we're going to put brackets, and yeah, because x is greater than negative 5/4, right? So it's facing to the right, and then it's also less than positive 5/4. That's going to the left, and it's everything shaded in between. Okay. Yep.
Now, does that mean that you can use the number negative?
Yeah. That's what the bracket. That's what's what the bracket. Remember the old days we put a circle and we colored it in. The bracket means the same thing, except the bracket tells you a little bit more than just the dot. The bracket tells you, okay, it's everything this way and everything that way, and the parentheses, same thing. It kind of tells you the direction that the thing's going. So that's kind of a nice way about the brackets and the parentheses versus the open circle and the closed circle. Okay. I guess I'm trying to I'm trying to rationalize reasons why it might be better to use this notation than the old notation. To tell you the truth, I really don't know why they do this. Yeah, but I mean, the book uses the brackets and the parentheses. I can't really remember, to tell you the truth, like in college, doing this kind of stuff. So I mean, we went way beyond this stuff my first class in college, so I can't remember exactly, but this is a college algebra book, and it is a book that they actually would use in college. Of course, depending what college you go to, they would use different books. This is probably old, so they probably never use this anymore, but you get the idea. All right? They just ask you to graph it, right? They don't even... No, they say solve it. So they also want you to write it in that... what's the form? Interval notation, right. So once you got the graph, though, it's simple to write it in interval notation, isn't it? So you put a parentheses, or a bracket, sorry, negative 5/4, 5/4, bracket, and there you go. So that's interval notation, and that's your graph. On that particular problem, they ask for both. They don't always ask for both, but they do on that one. We good? All right. Number 22. Let's see, where are we? There we go. Okay, it's one of these deals. 5x plus 4 over 5x squared plus 3 is greater than 0. Alright, what do you think? What's our first step here? We already got 0 on the right-hand side, so that's kind of nice, isn't it? So what do we do over here? And when we already have the 0 over there, right, set them both equal to 0, right? Okay, so it's negative 5x plus 4 is equal to 0, and then 5x squared plus 3 is equal to 0. All right, let's figure out what x is equal to, and then we'll go from there, right? Because what we're going to do is we want to figure out what numbers make this greater than 0, what numbers make it positive, correct? All right, so we're going to find out, okay, if they're both 0, what's this going to be? What's the sign of this going to be? What's the sign of this going to be? All right, and then we can determine from there. So let's see what we got. We got -4, right? And then divide by -5. 4/5 again. They like that number, don't they? Actually, it was 5/4, wasn't it, the other one? All right, so that's that. And let's do this. -3, -3. So, I see something. It's going to be weird. -3 divided by 5. So watch this. X squared is -3/5. So what's x? It really doesn't exist, does it? Okay. Not in the real numbers anyway. Take a peek at this answer. Okay, that makes sense. So this, I mean, you could take the square root of this, and then it's what? The square root of 3/5 I. It's an imaginary number, but we're talking real numbers here. We're not talking imaginary numbers. So just forget this whole part right here because it doesn't come out to a real number. So let's just deal with this. All right. So if x is equal to 4/5, let's see what this is. Let's see if it is actually greater than 0, and we'll take a peek. Actually, let's do this. Let's make a little number line. And it says x is 4/5. So we're going to put 4/5 right here. Remember what we're going to do? We're going to pick numbers to the left or to the right. What do you think would be an easy number to choose? How about, this is positive, right? So 0 would be over here, wouldn't it? Okay, so let's try a 0 and see what a 0 does to this. All right, so I'm going to try, because watch, any number to the left of 4/5 is going to give you the same value as far as positive or negative. All right, so you just pick any number to the left of 4/5. What's a super easy number that's to the left of 4/5 that we can plug in? Yeah, 1. Well, 1's actually not to the left of 4/5. 1's to the right of 4/5, isn't it? Because 4/5 it's what? It's 8/10. It's 0.8, right? So 1 is to the right. So give me we already said it. What's an easy? 0. Okay, 0 is a number. So let's plug in a 0 and let's see what kind of a sign we get. So put a 0 in for this. -5 times 0 is 0. Plus 4 is +4. Stick a 0 in for this. 0 times 5 is 0. Plus 3 is a +3. I don't really care about the 4/3. I just care about whether it's positive or negative. Okay, and it's positive, isn't it? So that means any number to the left is going to give you positive numbers. Any number to the right is going to give you what? A negative number. Just for fun, let's plug in a number just to see, just to make sure. A 1, right? So 1 is to the right, isn't it? So let's plug that in. -5 times 1 is -5 plus 4 is -1, right? We'll put a negative. Let's put a 1 in for this. 1 squared is 1 times 5 is 5 plus 3 is 8, which is what? Positive. What's negative over positive? It's negative, isn't it? So it does work. Would you agree? You could pick any numbers. You think, well, Mr. Hamburg, you just picked 1. You picked the number that makes it work. Nope. You could pick any number to the right of 4/5. It's going to make this thing come out negative. But I don't want the numbers that come out negative. What do I want? I want the numbers that make this thing come out positive, greater than 0, right? Because that's what it says right here. So I'm going to pick all the numbers in this direction. So, so what am I going to pick? Can we include 4/5? No, because that would make it equal 0. This doesn't say equals 0. If I stuck a 4/5 in for this, it would make this thing 0 over whatever. All right, so we're not going to include 4/5, but it's everything where? To the left. It'll be like that. Okay, now how do we write that in interval notation? Oops, went the wrong way on that. We write what? From -infinity all the way to where? 4/5, and it's open at 4/5, and it's always open at infinity, and so that would be the interval notation right there, and that is the correct answer I read off, isn't it? Yep. Does that make any sense at all? All right, so that's what we do when you have a fraction like this, and you already have 0 over here, go ahead and just set them both equal to 0. In this case, this didn't come out to a real number. Now sometimes that bottom, it will come out to a regular number, won't it? Right? So you got to put it on here, then you check to the left, check in the middle, check to the right, and see which ones satisfy this inequality. So we're just looking for the ones that are greater than 0, positive. That's why we just picked all these numbers over here. We good with that? All right. That was 22. What was the other one? 30? All right. What color haven't we used? What about this rust color? That's sounding beautiful. Here we go. What's that look like up there? Kind of brownish looking, I guess. That's all right. Do something different. So 5/8 plus we're on 30, yes. 2/11. Alright, this is absolute value. So remember, we do two different equations, don't we? Or in this case, not equations, they'd be inequalities. But we do two different inequalities when you have absolute value. The first one, you write down exactly what it looks like up here, except you just get rid of those absolute value symbol things. Okay, so let's write it again, but let's just get rid of the absolute value. I'm not changing anything, not this time. Alright, so I just write it down exactly the way it looked before. Then I have to write a second one. I do have to change a couple things here. What do I have to change here? Right, the inequality and the sign of this number. I got to change both of those. Okay, the left side stays the same. That doesn't change. It's just the right side. So instead of greater than, it's now less than. Instead of 2/11, it's what? Negative 2/11. And then we just go through and we solve for x. Okay? Now it's fractions. I understand. You just love fractions, don't you? So let's see what we get. We got to solve for x, so what do we get rid of? The 5/8. So we subtract a 5/8 and we subtract a 5/8 from here. Let's see what we get. That's 1/9 x is greater than. What do we need to find here? Common denominator. What would that be? 88. Correct? Yep. So let's think. 11 times what? 8. 2 times 8. 16. 8 times 11. Negative 5 times 11. Negative 55. Right? Add those up. So, I don't know. What's 55 minus 16? That would be 39. Did I do that right? Negative 39 over 88. Right? How do you get rid of that 1/9? It's being multiplied, so yeah, you would think divide, but it's a fraction, so what do? You multiply by the reciprocal. So you multiply by 9 here, and you come over here, and you multiply by 9 over here. Cancels. X greater than, nothing goes, right? Nothing goes into 88 and 9, does it? Nope. I don't know. Who's got a calculator? What's 39 times 9? I don't think anything goes. 351. Is that the answer? Oh, yeah, it does come out to that. Okay, good. Sometimes when they're ugly, you always second guess yourself, don't you? But this comes out ugly, and it's correct. All right, so it's negative 351 over 88. All right, good. So that's part of it. Let's do this part. Oops. Let's subtract the 5/8 again, but this time we have a negative. So it's 1/9 x is less than. Common denominator, same exact thing, isn't it? That's times 8, that's times 8. But look, that's a negative 16 this time. And this is still negative 55. So now we have to add those up. So that's what? 71, negative 71 over 88. Multiply both sides by 9, just like we did earlier. And x is less than, what is that, 639? 63, right? 9 sevens are 63, and 9 times 1 is 9. Negative 639. It's not like I'm a math genius. You could have done that, couldn't you? In your head. 9 times 1, 9 times 7. Yes? Anybody agree with me or not? Okay, over 88. Alright, so, whoopsie daisy, I don't want that. What is we got to write this in interval notation, correct? So I like to graph it just to see what's going on. So what's the smallest of these two numbers? It's that negative 639, isn't it? That's the smallest number. And this is a larger number, negative 351 over 88. All right, let's see what's going on. So what are we doing with that 351? It's greater than. So that would be, let's change colors this time. Let's go green and brown kind of go together, right? So watch. It's going to be open, and it's greater than, so it's going to be everything to the right. And this is less than negative 639, so this goes this way, and everything to the left. All right? And now, we're ready to write it in interval notation. We go negative infinity to negative 639 over, it's supposed to be 88. It's open here and it's open here. Union with negative 351 over 88 all the way to infinity and beyond. Seems like I always have to say that. All right, and there it is. That's your answer. They write it dumb, don't they? Yeah, I got it right. They wrote it dumb. This is the way it should be written. And I think they've made that mistake before, haven't they? Yes, they do. But I'm not perfect. I make a lot of mistakes myself. So, but they're not supposed to, are they? All right. Ryan, you said you had some other questions on... Alright, let's take a look at that. T minus 1 to the 2/3 plus 2 times t minus 1 to the 1/3 minus 8 equals 0. Alright, this is definitely a substitution problem. Wouldn't you agree? Doesn't this really look close to x squared plus 2x minus 8 equals 1? You're like, no, it doesn't, because there's no x, and that's a 2/3, it's not a 2. But if you think about it, watch. If this thing right here was what? An x, right? Do you remember this? So we let x equal t minus 1 to the 1/3. Wouldn't you agree with that? If that was an x, then what would this be? This would be an x what? Squared. So really, I could write x squared plus 2x minus 8 equals 0. All right? So let's see. Does this, yeah, 4 and 2, right? This factor's real nice and pretty, doesn't it? Got an x here, got an x here, got a positive 4 and a negative 2, right? Multiplies to be negative 8, adds up to be positive 2. Set them both equal to 0. You can do that in your head. What's x equal? Negative 4 and what? Positive 2. But that's not our answer. We don't circle that, do we? Because we're not solving for x. We're trying to find t. So we're going to go back to this again. See, x is equal to this, isn't it? So what I'm going to do is I'm going to put 2 of these, right? Because x is equal to 2 different answers. So I'm going to put this equal to negative 4. I'm going to take this and set it equal to 2. So let's do that. So it's t minus 1 to the 1/3 equals negative 4. And t minus 1 to the 1/3 is equal to 2. We good? All right, let's do the math. Let's get rid of this 1/3. It's the exponent. How do I get rid of that? Take it to the 3rd power. Cube it. That's right. Take it to the 3rd power. That'll get rid of it here, but I have to take this to the 3rd power as well. So let's see what I have. I got t minus 1 equals negative 4 to the 3rd. Negative 4 times negative 4 times negative 4, which will be negative 4 times 4 is 16. 16 times 4 is 64. Okay? Add a 1, and what do you get? Negative 63. So that's one of my answers. Okay? check. Yep. It's always nice when they get the same thing I get. All right. So, and we do the same basic math here. Cube this, t minus 1 equals 8. So t equals 9. And there it is. There's your two answers. The key to this problem was understanding to make it a substitution, wasn't it? All right, because you look at it and say, oh, you know, it kind of looks like a quadratic. I got something squared, right? And then I got plus 2 something to the first. So let's just make this thing an x. This thing is an x squared, so it just works out just perfect for us. So what started off looking like a crazy old equation we could never solve for kind of ended up to be pretty pleasant. Wouldn't you agree that that's fairly pleasant quadratic? Yeah. Then you just work it out nice and good. Then you just replace that or set this equal to both of our answers right here. And then you just go ahead and solve for t. And really solving for t wasn't that bad, was it? Cube both of them, right? It wasn't that big of a deal to cube it and add a 1. That's really simple. Do the same thing over here. We're good to go. All right? Good. What else? Got a few minutes here. Nothing? Well, all right. So, test when? Tomorrow. Tomorrow. Nope. Wednesday. For what? 13? Is that right? Today's the 12th. I think today's David Letterman's birthday. I don't know why I know that, but well, my son's birthday's on the 10th, so I remember that, and for some reason I just remember his birthday. I think it's that day. I think it's my nephew's birthday today too. But anyway, there you go. All right. Have fun with it. All these are online, all right? These questions we've been asking yesterday and today, so you can always go and look at those again. All right, that's it.